Hi students, this is a video for number 25 in your multiple choice review packet for chapter 7. Great question about the about differential equations and how those play into effect with a word problem. And I'm going to give you a much better explanation than we came up with on Friday. So this question was kind of puzzling all of us, including myself. And what I need to tell you is that we really just weren't reading it closely enough. So if we read this one closely enough, I'm right here on this first phrase, and that's the part that we weren't reading closely enough. The number of bacteria in a culture is growing at a rate of 3,000 e to the 2t over 5 per unit of time. So the key word, I guess, there is really the rate. So what we needed to interpret this as is that's not y. If y is my population, we were interpreting it this way. I didn't mean to do that. Let me get my pen back. We were interpreting it as that was giving us that the population was equal to some initial amount times e to the 2t over 5. And that's not what or we were using y, but same thing, I'm using p for population. What the question is really saying is that they're saying that the rate of growth, that would be dp dt, is 3,000 e to the 2t over 5. Just pretend that says, here, let me try to make that a little neater. So that's what we needed to start with. What I'm going to do is I'm going to go to another screen and I'm going to pick up with this equation. And we're going to look at how that can get us to actually making sense of this with what we knew the answer should be. So join me on the next page, but I wanted to point out the wording in that question and how we need to really pay attention to that. And like I said, I overlooked that also. So that wording is indicating the rate of growth of the population. That means a derivative, or in calculus notation, dp dt. So new page, the equation that I just had a second ago on the screen was dp dt equals 3,000 e to the 2t over 5. So now this becomes an issue of let's solve the differential equation, and because we actually need to get to an equation that says p equals something. So to try to get there, I'm going to separate my variables and go through the whole process of how I solve a differential equation. So dp is equal to 3,000 e to the 2t over 5 dt. I'd really like to get that to be e to a simple power, so I'm going to change that to just looking ahead because I'm going to integrate both sides. I want to get that e to the u du, so I'm making my u be 2t over 5, or 2/5 t. Du dt then is 2/5, and if I put that in terms of dt, as most of you like, that would be 5 du over 2. So my dt right here, I'm going to replace with 5 du over 2. And then I am going to go ahead and, left side didn't change, differentiate or take the integral of both sides. So I'm ready to take the integral of both sides. Remember, that's just a 1 dp. So left side looks a little weird, but that's just giving me a p for population, or you could have used y, whatever you want there. P equals, and I've got antiderivative. I can pull out the 3,000 and the 5 and the 2. Will all come out, and then I've just got e to the u du. So 3,000 divided by 2 times 5 is giving me 3,000 divided by 2 is 1,500 times 5. I'm getting 7,500 for that constant e to the u plus c. So 7,500 e to the u plus c. Now I'm going to go ahead and put my u back in. So that's really 7,500 e to the 2t over 5 plus c to solve for my initial condition. This is my general equation. I want to get my particular solution for my general solution. So I'm going to go ahead and substitute in. They told us that the 7,500 bacteria were present at time 0. So that would be, let's go ahead and make that 2 times 0 over 5 plus C. Let's solve for C, and my answer, I know that this is 7,500 when time is 0. So putting my 0 in, obviously divide by the 7,500. E to the 0 is just 1. 7,000, I'm sorry, subtract the 7,500 because I now have 7,500 equals 7,500 plus C, and I'm ending up with, no surprise with what we thought the equation should be, I'm going to end up with C equals 0. So get rid of this C, and my particular solution is actually that. That should explain where we get in the 7,500. It's not just magic. It's from solving the differential equation, and that's what we said it should have been based on what we knew about our initial condition. Continue there to answer the actual question by plugging in. They want to know how many bacteria are present, what's the population when T equals 5. So that would be put a 5 in here for T, and that's getting us the answer of C when we go ahead and do that. So hopefully that helps give a little explanation to why they gave us that original equation and why that looks so weird to us.